Hello everyone, welcome to the WLAN Troubleshooting Basics session. I'm your instructor, Wang Pulian. In the previous sessions, we have already learned the basic concepts of WLAN. You know how to configure an AP to go online. However, during the configuration process, you may encounter many issues. For instance, if you want to configure this AP to go online and emit a signal, you might face several problems, especially if you are a beginner or unfamiliar with WLAN settings. Even our instructors might make minor mistakes during demonstrations.
It can also lead to various malfunctions. Therefore, it is necessary for us to grasp how to perform WLAN troubleshooting. This troubleshooting is not only about issues we mentioned earlier, like getting an AP online or whether a terminal can access this AP. Faults can occur in other areas as well, such as handling faults at the physical layer. If we are on site, how should we conduct WLAN troubleshooting?
Moreover, WLAN troubleshooting differs significantly from troubleshooting wired networks. For instance, in wired troubleshooting, an intermediate method might be to simply connect an Ethernet cable to capture packets. In wired networks, packet capturing is relatively straightforward. However, with WLAN or wireless networks, capturing packets is more challenging as you need to capture a wireless frame. Capturing this requires specific network cards and software. WLAN troubleshooting is more complex. Today, we'll discuss some simple troubleshooting techniques since we are in the IA phase. Our main goal is to grasp the overall configuration system and ensure there are no issues during configuration. This is the first step we need to focus on. The second point is about understanding some issues that might arise in certain engineering cases and how we should troubleshoot them when they occur. Today, we're talking about the basics of WLAN troubleshooting. Let's first look at the components of this course. It's primarily focused on AP online faults, endpoint online faults, and potentially configuration issues. Later, we will discuss which aspects we need to emphasize when talking about the troubleshooting process and what we should pay attention to. After completing this course, I hope everyone will master the following. First, knowing what kinds of WLAN failures exist. Second, the process of WLAN failure troubleshooting. Third, listing some common WLAN issues. Additionally, there will be many new commands related to configuration that you'll learn. Today, we'll focus more on operational maintenance commands, particularly display commands. This course is structured into 5 different chapters, starting with an overview of WLAN troubleshooting. In the overview section, we will focus on explaining some processes. The following 4 chapters focus on common failures. Then we'll discuss what potential issues and reasons might arise. Now, let's take a look at what the typical process for troubleshooting a failure looks like. Nowadays, many engineers tend to be rather restless. For instance, as soon as they receive a failure notice, they dive right into investigation without assessing anything, which is incorrect. So let's discuss the correct approach to troubleshooting. The first step should be to evaluate the severity of the failure. Understanding the phenomenon of a fault or knowing the impact level of a fault often causes our troubleshooting speed to change significantly. For instance, if your AP goes offline, we need to determine if it's a small-scale or large-scale outage, as different investigation methods are required. A large-scale issue may indicate a core problem, while a small-scale one might suggest an issue with a switch. So, the first step in assessing the severity of the fault is a very important part. You need to analyze it specifically, and then, if you think it's a relatively serious and urgent fault, you might want to escalate it to a higher level. For example, you might need R&D support, because the goal is to resolve the fault as quickly as possible. That's the first part. We need to clearly understand the severity of the fault. Secondly, it's about collecting the fault information and then writing a fault report. Because sometimes if you need to submit a ticket, you'll need some fault information. This part is a kind of documentation thing. What is its use? For example, if you work on something yourself and can't troubleshoot it later, with this report, I can directly submit it to senior engineers or developers. After they review this information, they'll have a general idea of what the malfunction is. Otherwise, what else would you have to do? You'd have to explain it to them again, which greatly affects efficiency. This area involves more standardized practices. Then the third step is to locate our malfunction in our large WLAN network. First, to determine where the malfunction occurs, which device might be causing it, or which command might be leading to the malfunction. First, we need to pinpoint exactly which part this issue relates to. This part is also quite crucial. How do we diagnose this problem? For example, how do we deal with packet loss in wireless networks? If I'm currently using a PC to ping a server and experiencing packet loss, how do we find the device responsible for the packet loss? What exactly is the cause? Wired issues are slightly simpler, while wireless can be more complex due to the air interface design. If the air interface is fine, you might need to use traffic statistics and various methods to identify which device is malfunctioning. Once the issue is identified, we still need to troubleshoot it. What is the typical approach for troubleshooting? Don't we have the OSI reference model? Generally, we follow this OSI model. What's the first step? Check the physical layer. Why the physical layer? Because although there are many issues in wired networks, most of the time it's just the network cable that's problematic. For example, there could be issues with the fiber optic line, the AP could have problems, or the switch's power supply might be faulty. In my previous experience with WLAN maintenance, most remote solutions involved simply rebooting the AP or the switch, which resolves 90% of the issues. 90% of remotely handled malfunctions can be resolved this way.
Although AP is considered an industrial-grade product, it can still encounter some issues during long-term use, especially in high temperatures during the summer. Possible issues include crashes, instability, or some APs might be damaged. These are generally faults of the AP or physical faults, which can typically be resolved remotely. However, if you go on site to address them, there might be other hardware issues. If you have experience with projects, you would realize this.
Generally, the issues we encounter tend to focus on the physical layer rather than the second or third layer. Why is that? Essentially, network stability depends on system configuration. Normally, you engineers wouldn't randomly enter commands, right? If commands aren't changed, configurations shouldn't pose any major problems. However, if certain customer actions trigger a fault, we might need to adjust configurations. But generally speaking, there shouldn't be significant issues with such configurations under normal circumstances, especially in larger networks, like when you work for an operator. Can you change the commands of China Mobile or China Telecom just like that? Obviously not. If the command isn't the issue, then what's the problem? More often than not, it's issues at the physical layer that we need to be aware of during troubleshooting. The general idea is to determine potential fault causes and finally verify the service. We need to be precise in service verification, like checking remotely, because often our engineers don't go on site, and that's quite normal. We do have construction teams and maintenance personnel. Normally it's the construction team or maintenance personnel who are on site, while you provide remote support. In many instances, unless there's a major fault or the issue can't be resolved, then you'd go on site to save time. After arriving on site, what does the construction team do? They'll replace the AP or the network cable to see if it can be used. If not, they'll call you. In such cases, if remote support isn't enough, or once you've fixed it, what does the construction team do? They usually test the network with a mobile to see if it connects smoothly. Check if this signal strength is normal. At this point, it might not be enough. For instance, when working on university projects, you often needed the construction team to visit dorms, to ask students if they could connect to the network to see if the service was accessible, because in many scenarios, you might not be able to access our network. Moreover, when engineers are on site, they might not always have someone accompanying them to troubleshoot. Typically, you're alone or with the construction team's assistance. The usual fault handling process involves the construction team verifying or trying to fix it. If they can't, then you have to go on site to see if there are any other issues. If it's really unresolved, then you have to seek help or start capturing packets to determine exactly what the problem is.
Then on the device, you may also need to troubleshoot. This is a common fault troubleshooting process. Here we've learned the general process for fault handling. In the next class, we'll study in detail how to handle each step of the process.